Hi, everyone. Thank you for joining us today. It's now 3 o'clock, so I will kick off our live coding demonstration today with an introduction. My name's Sierra, and I am the Admissions and Program Services Manager with the Data Incubator. And we are a fellowship, scholarship, and placement program. We're really excited to have you join us here today. And we've promised you a really exciting info session that will be led by one of our instructors, Michael Cullen. But to start things off, I'll give a quick overview of our program and everything we do, and then we will pass off to Michael. And then at the end, we will open it up for some questions that you can send through the Q&A and through the chat as well. And just to let you know, I'm going to start off again with an overview of the program, and then we are going to have an hour-long session. So we'll try our best to get to all of your questions that you send through the chat. But if we're unable to answer all your questions, you can send those to admissions@thedataincubator.com, and we'll be happy to respond to those there as well. So our program focuses on training individuals to be a data scientist. And why is that important? So it's important to have the ability to work with the latest tools of unstructured and structured data to drive business values. And we see that data science and data mining is a real big need in the world today. Tons of companies have a variety of data that they need analyzed. So we see that this skill and this job is one that is becoming increasingly needed and is a popular role. So we want to help work individuals wanting to transition into the world of data science to help them have those tools to be able to work with these companies and meet those needs. So going over our fellowship program, so as it says here, it's not your average data science program. So it definitely is intense. It's a full-time commitment to participate in this program. So prepare to be learning from 9 to 5, Monday through Friday for those full 8 weeks. You won't have lessons scheduled throughout that 9 to 5 hour, but that's typically what we say to slot to ensure that you have enough time to complete all the projects and the work time as well. In addition to that, our program is thorough, so we focus on different tools each week, such as data mining, machine learning, TensorFlow, Spark. Those are just a few of the tools that are covered weekly. So it's a really thorough hands-on learning where you're doing practice, assigned mini projects weekly. You are meeting with your instructors, going over code review. So it's really helpful to give you those hands-on skills so when you transition into that world of data science that you are most prepared. So it's also a collaborative program. We help you to present and pitch your capstone project in weekly group meetings. So you'll be working throughout the 8 weeks on a capstone project as you've seen during the you'll see during the admissions process, and you get feedback from your peers and your instructors, and they really help you to refine that project and gain those tools to be successful. It's also a forward-thinking program, so we have a career coach that holds weekly presentations to help you present yourself to future employers. So with that, we help you to sharpen your skills through interview prep. We will help you with resume writing and services, and also we'll go over storytelling and making sure that you are best prepared to present yourself to future employers. And then it's also a career-focused program, so you'll be able to attend virtual networking events like partner panels, pitch nights, and also some of our candidates will have an opportunity to pitch their capstone project as well directly to hiring partners. So we do our best, even in this virtual environment, to still have those networking events so that this program not only helps you prepare yourself for the field of data science, but also taking that next step into acquiring that role as well. And so we admit 2 types of individuals into our program. So we have fellows. So fellows are granted a tuition-free scholarship, and they go to a select group of highly qualified and exceptional candidates. So there are very limited spots available and a very specific criteria for those that we grant those fellowship spots. And we do ask our fellows to leave any current position to attend the program and to interview exclusively with our hiring partner network. And then in addition to that, we have a scholar position as well, which they receive all the same resources that our fellows do, but there is a tuition cost associated with that. Our program is only online as of now, so the online tuition rate would be $9,000. And there are some financing options available for that, which I will go over. into our next slide. But once we get into that, I will pass over to Michael to start the live demo, and then we will switch back over for some more program information and then open it up to the Q&A as well.
All right, well, I do believe that is my cue. So welcome everybody. As Sierra said, we're going to be covering, in addition to some information about the fellowship, I'm going to be giving a demo of some of the, not only the techniques used in the practice of data science, but also, how we as data scientists, approach problems and translate real world, business cases into something that is, quantifiable, something that we can ultimately share, quantitative results with someone else. So with that being said, let's see, I'm going to be going through some interactive code. Today, I'm going to paste a link in the chat box. So that should be this one right here. This Q&A. This is the chat box. So I put a link in the chat box it's going to take you to mybinder.org. Once you're there, should go ahead and share my screen now. Content, share, Google Chrome. That will take you to, this link that you see here, which will load a collection of Jupyter notebooks, or I suppose just one Jupyter notebook, from a GitHub repository. When you get here, go ahead and click this launch button. Now, this is going to take a few minutes to get running, but it is going to let you follow along with all of the code that I'm running just in your browser without having to, really fuss around with anything too much. So this will, start spinning up a notebook that you can use. Again, hit launch. Once that loads up, you're going to end up at a page that looks like this for the most part, minus a few of these files. And you will see this thing at the top that says exploratory.ipynb. And that's going to get us into the actual content we'll be using for today. So for today's demonstration, I have prepared a little bit of exploratory analysis that I might do around a real-world business problem that someone in a non-data science practitioning role might bring to me. And so I show this, again, not just to show some of the, the range of sophisticated tools and techniques we have at our disposal, but also the process that I would go through and that a data scientist would go through of translating a broad goal into something, that starts to be more quantifiable, perhaps in terms of a machine learning problem. And as well, to demonstrate some of the steps I would take in beginning to, interrogate and explore a data set and to start to eke out general trends that we might be able to put to work. So again, just one more time, if you click on the link I put in the chat box, that is going to take you here to this My Binder link. Now, Binder, as I said before, this is a service that lets us spin up some Jupyter notebooks from a GitHub repository. So some people might not be able to find the link. I sent those to the host. I'm so sorry. Probably would be ideal if you could see the link. So it should be there now. Sorry about that. Again, click launch. That'll take you to a page where you can open up the notebook. It says exploratory. And once you get in there, go ahead and run a few of these cells. I'm also going to note really quickly, for those of you who may not have seen Jupyter notebooks, this is what we're looking at right now. This is a tool for writing and executing code interactively with nicely formatted text, images, and diagrams, and so forth. This is something that is extremely commonly used in the field of data science for exploratory analysis, for preparing reports, as well in general Python programming, and actually as well other languages too. So I use these all the time. Oops. I use it all the time. It's definitely a preferred tool for exploratory analysis. Even if I am starting to develop some pieces for actually like a piece of software, an automated data pipeline, for instance, I still tend to build a lot of the pieces in these notebooks where you can kind of tool around and work interactively. So all that being said, again, for those of you who aren't that familiar, what we're looking at are a bunch of little chunks or cells containing, in some cases, code that we can run, interactive Python code, and in some cases, text. And we could also see we have hyperlinks, and we could also embed pictures and so forth. So if we wanted to run the code in one cells, you could do one of two things, perhaps a couple other things. At the top of the toolbar, you might see this button that says Run. That would run a cell. What I will be doing throughout this demo will be just holding Shift and pressing Enter. So you won't see me mousing up to this Run button. Just the Shift Enter shortcut will just be a very fast way to execute the code cell and keep going. So as you do start following along, I know those binder notebooks will take a little bit to spin up. Just be sure that as you start scrolling down, to run every cell on your way through the notebook. So first here we're going to just import some libraries we're going to be working with, pandas, and NumPy, matplotlib for some plotting, and kind of go from there. I'm also going to make sure this cell is run before I go on, but that is an overview of, again, the broad goals of today's demo, an overview of the kind of format we're using with Jupyter notebooks and with Binder. So now let's talk a little bit more about the overall intent here. So as I said, I don't just want to focus on the how of data science. I'd like to talk a little bit more about perhaps the why and the what, basically the way that our work interacts with our non-data science, practicing, non-technical by some accounts, collaborators. We are working a data science job. We are not only working with or for other data scientists. We are likely collaborating with people in, perhaps marketing and operations and sales departments and engineers who are looking to us to, come up with insights. Sorry? Sorry about that. And so what does this process of collaboration really look like? This is, how should I say this? In working, in engaging with, again, these non-data science collaborators, it is often the case that you may, someone may come to you, you may be in conversation with, and let's say in this case, someone in marketing at your company or who you are otherwise collaborating with. And they may come to you with a fairly broad goal or question. For instance, how can we make more successful social media posts? How can we do better on our social media? Something like this that has a few intuitive interpretations, but is ultimately kind of qualitative, ultimately very broad. It speaks to something that we would like to do, not necessarily to how we're going to do it, and certainly not to the numbers that we can really boil it down to just yet. And in facing a question like this, as a data scientist, and something that you do this is a process you do through communication with your collaborator as well, you might think, okay, well, when we say do better, on these posts, what is it exactly that we're looking to improve? We could imagine that there are a number of metrics that might accompany a social media post. Pretty much any platform has some notion of liking something or commenting on it or sharing it. If we are posting links to our website, for instance, or to some content, then we can track if people are clicking those links. And so we have all of these different possible metrics. When it comes down to, perhaps in the future building a machine learning model that will predict one of these metrics, well, it really is going to matter for us which of these that we choose. They are likely somewhat related to each other, but it's often the case that one of those possible metrics might more aptly reflect the actual goals of our collaborator. So for instance, do we want to generate posts that get a lot of likes, but for which no one actually follows through to our website or has converts in some way? Posts that get a lot of comments, but they're all negative? Not necessarily. Perhaps we do. And so there is this conversation that has to happen. We need to drill into what we're actually trying to improve, what we're hopefully potentially going to be predicting. And so that's part of this refinement process, refining the problem that we're trying to solve. That might point us to, if we are building a predictive model, what would we be predicting? We also might look into, okay, well, what data is available to us? And that I'm actually going to touch on in a little bit with some example data. Well, I guess let's actually address the data now. So we are working with a social media popularity data set today, sort of a canonical data set shared by the UCI machine learning repository. So you can follow the link right here in your notebook here. And let's look at the brief overview of it. And this is just kind of in general, a really nice open source repository of commonly used machine learning data sets with fairly standardized and fairly effective documentation. And so what we're working with here is a set of news items, basically overviews of news articles, social media feedback on a few different platforms, Facebook, Google+, and LinkedIn. We have some more information on the data set. So this is a period of 8 months from November 2015 to July 2016. We have about 100,000 news items on 4 different topics: the economy, Microsoft, Barack Obama, and Palestine. And we can also look into some of the attributes, some of the features that are contained in these files. So we're going to have a file that's kind of an overall news data file where we can see the title of some article, the headline for that article, the outlet that originally published it, the topic, one of those 4 topics as above, when it was published, date and time. We also have access to some results of sentiment analysis here, which I'll touch on in a second. And we have the final overall values of the popularity on each of those social media platforms. Now, in this particular data set, we are not given distinct measurements of things like likes, comments, shares, click-throughs, and so forth. We are given a single value that is sort of a, I suppose, to some degree, standardized popularity score. And that's what we're going to be looking at. I will also note that for each of those sites, Facebook, Google, and LinkedIn, we will also have a time series of popularity for over the first 2 days after publication, which we can consider as well. So back to our notebook. That's a little bit about our data. Again, we are using these news articles and, relating some of the information we have about those articles to how popular they were on various social media platforms. We are potentially doing this because, we're, let's say, collaborating again with someone in marketing who is trying to understand or maybe improve our performance with our social media posts. And the sort of missing link here, once we know what we want to predict, we are doing supervised learning. And in this case, we only have that popularity score. Then we need to think about, okay, well, what can our collaborators actually do with this information? If we tell them that this will be this popular based on all the data we have, what actions can they take if they want to improve that popularity? This is going to inform our process, right? Broadly speaking, our collaborators might be able to select between various articles to promote, and by spending part of the marketing budget, to create ads from those articles in those pages. might be able to strategize around perhaps what time of day we should be posting or what day of the week we should be posting more. We also have, we could consider perhaps some more sophisticated, more complex actions that could be taken, such as reworking the way in which we write headlines or titles of articles, or even if we had a little bit more data, maybe changing the types of images we use. That being said, those last three actions that we could take, those last three levers that we could pull if we wanted to improve our performance, with these posts, they're going to be a little bit more difficult. And what we'd like to do first is see, can we improve by just changing the things that are going to be easy to change? This is another really key idea in proposing a solution or an approach to a data science problem, or proposing to the data scientific approach some business problem someone brings to you. It's not always a great idea to reach for the most state-of-the-art, sophisticated, and interesting, sub-problem we can find. We don't want to reach straight for some neural network that analyzes the entire text of the article and just predicts how popular it's going to be, or some convolutional neural network that looks at the images that we're posting along with these articles and seeing how that affects popularity. Can we find something valuable in the most simple and easily observed features that we have? And with that, can we make an easy change and get something valuable out of making that quick and easy change? That's kind of an overview of what this process looks like. And to start investigating those possibilities, I'm just going to go over how I might do some exploratory analysis with a data set like this. Now, we might imagine that this data set represents data that we have within our company about our recent performance. We also might imagine that we are bringing in some alternative data to get a better understanding in a broader sense, across the field, what types, what characteristics of, posts that we can observe might be affecting that popularity. We could think of this kind of in either setting, but I will say, as we load in this data, that I am restricting the topic to just Microsoft, along this sort of setting in which maybe we're working for Microsoft, we're looking at some information we have about our social media posts. So bringing in that new data set, going to do a few other things. So we're looking at the popularity on Facebook, Google+, and LinkedIn. So I'm going to restrict the articles in our data set to just the ones that were posted on all three of those sites, that were seen on all three of those sites, right? We also, and we can take a look at our data set now. So I'm just kind of creating a new cell, taking a look at the basically head of this data frame, kind of working in pandas here for this tabular data. We can see that we have, a few different columns. We have a title for an article, a headline, a source from which it was published, when it was published, some information about the sentiment, basically how positive or negative those words were, and then those three scores. Now, some of these sources look fairly recognizable. Some of them maybe not so much. And because we want to stick to data that's going to be valuable for us, that we can make meaningful predictions or spot meaningful trends from, we're going to restrict our analysis to sources that come up fairly often. And to that end, I'm going to be using only sources that have at least 50 articles here. Turns out there are 75 of these. Now, another thing I'm going to do is I'm going to take this date field, which right now is just a string of characters, and I'm actually going to turn that into something a little bit more useful for us, which is basically a number of new columns that actually tell us, perhaps the month, the day of the week, the hour of the day, and so forth, as well as the year. Instead of just one single string, like this publish date, we could now say, okay, well, this one was in 2015. It happened at 5 a.m. This one happened at around noon. 6 here means it's going to be a Sunday, 0 through 6 for Monday through Sunday. And so we're going to be able to get a little bit more easily identify some trends with these transformed features. Something I'll very commonly do if I'm looking at temporal data. Is there a pattern in times of day, days of week? across multiple years? Is there an overall trend? So things like that. Also, just, this helps us get a general idea of what the data we're working with is. We see that, after all our filtering, a lot of this is happening in 2016. Is this immediately telling us something we really need to know? Maybe it is and maybe it isn't, but the more that we can visualize, these features, these columns, perhaps the relationships between these columns, the better we're going to do. So after doing some more of that data processing, we could also look, for instance, at, okay, well, on what day of the week are these articles published? And so we have kind of in descending order here, and we can look at this in a little printout as well. But we have, and again, this is going to be Tuesday, Wednesday, Thursday, Monday, Friday, Saturday, and Sunday. Same thing we see down here. And again, this is something I do as exploratory analysis. If I'm just going through a data set, I tend to move kind of quickly when I generate these kinds of plots. So rather than creating figures that I would be, sharing with my collaborators in a presentation, where I would, of course, be formatting and labeling things, just a quick and dirty way to, visually inspect the data. So tends to be a little bit, not extremely labeled. But we see, for instance, that Saturday and Sunday, we're not publishing a lot of articles. We can see an overall trend there, right? It's like a lot of the kind of already in place strategies involve posting on weekdays. Now, maybe that's because it's more effective. Maybe that's because, content, social media managers or social media marketers, I should say, content designers, are working Monday through Friday. Maybe it's because they found that people are, clicking more articles during the work week. Perhaps they click more articles while they're at work. This is going to ultimately be conjecture because we don't know necessarily when those articles are being viewed, at least not without a little bit of work, but it starts pointing to some other angles we might approach this data from. Again, just in this process of visualization and exploration, we can start just posing a number of hypotheses that might become really useful for us. Now, we had these columns that said sentiment. Show the kind of first few rows of this data frame again. So we had, for instance, a title like Microsoft is offering, a £100 discount on original something. We have a headline, and we have some sentiment on these. Basically, what this is going to tell us is if we're at 0, this is like sentimentally, kind of like emotionally, a neutral statement for the title. It's not very positive. It's not very negative. Likewise for the headline. If this is very negative, it means that this is a very negative sounding headline. If it's very positive, it sounds like, well, good news. Something that we can just sort of, keep in mind. We might imagine that, whether an article is particularly positive or particularly negative, perhaps that has some influence on its popularity. Perhaps people want to click on something that is exciting, that seems like very good news, that might have very positive sentiments. Perhaps a story might be very, very negative, maybe some sort of scandal or something like that. So we have this notion that maybe the sentiment that we've computed on the headline or the title might tell us something. Now, we can look into, some examples of high and low sentiment, but before we do that, let's just look at those actual values that we get for the sentiment title. So here we just sort of can see like the density of those sentiment values. It looks like we have a lot around 0. It looks like the average of them is actually just basically right around 0, and that it looks fairly symmetrical on either side, perhaps maybe with one outlier all the way out here around -1. So maybe there is and maybe there isn't a lot of information there. Another thing we might consider doing is let's just say, okay, well, let's go back to our data frame. Let's make a scatter plot. On the x-axis, let's put our sentiment. On the y-axis, let's put our popularity on Facebook. Here, it looks like there's not really an obvious trend. I suppose some of these articles that actually have fairly neutral sentiment are more popular, which might not map onto something we might have expected. We might not be able to, come up with a general theory for why that's happening. but it is something we're observing. We could try this as well on our other sites. LinkedIn looks about the same. Those more neutral articles seem to be performing better, and there seems to be, as we saw before, a lot more articles that are sort of in that middle range. We could do this for the headline as well. We could see that this basically looks the same way, although now maybe the center is a little bit to the left of 0. So perhaps those negative headlines actually might be doing a little bit better. But in any case, I think actually I have some stuff in here that I was trying to show. Sorry about that. And so, again, this just lets us start peering through, what is in this data set. And let's see, before we get into a couple other things that we could do, we might look into, okay, well, what values, right? What sorts of titles or headlines do we actually see associated with high sentiment and low sentiment? Just to dig in a little bit more on what these numbers might mean, right? So again, we have our data frame, variable news. We might say, okay, well, let's take this and let's sort this on just sort values. Sort values. Let's sort this using the, let's say, sentiment title. So what types of titles are going to be, in this case, maybe the worst? It's going to be reflect most poorly for sentiment. So when we sort these, we're going to sort numerically on this column in ascending order. So if we were to look at the first 5 articles there, they would have the lowest sentiment per title. So like this one says something about a massive problem. This one says something about being deeply sorry. And we could, want to see those full titles, perhaps dive into those. Maybe you get the values there. Fixed a massive problem at Microsoft. Deeply sorry for its offensive chatbot. Retraction by Microsoft. Interestingly enough, why Microsoft has taken off in the cloud era maybe doesn't seem that negative. But that's, ultimately a result of some model that we didn't. Serious new problem. Another one that seems, pretty negative. And we could try this, for the headlines as well. Serious authentication bypass flaw. Spell out when a problem is your problem. Problem is Microsoft's problem. Annoying stuff. Ads by default. Let's see. Forced to pull the software update caused havoc. So we can see some of these words that might be kind of cluing us into positive or negative sentiment. Again, not immediately clear to what degree those might be really valuable to us just in sentiment. Perhaps we can do something else with these words that might be more predictive, of popularity, for instance. So here I might start doing some just kind of brief exploratory machine learning modeling. I might just see if I can make some basic supervised learning models that might just take in some data we have and try to predict the popularity of future articles. And I'm going to move through this kind of quickly as I've moved through the other code kind of quickly. This is really not intended so much for a tutorial on using these tools as a walkthrough of how I or how another data scientist might approach these sorts of problems. So that being said, now that we know a little bit about our data, let's see if we can find some signal. Let's see if we can ultimately make some decent predictions. So we're going to define a new data frame based on our news. And take a look at this data frame. So we have the title, we have the source as before, we still have sentiment, we have all of our temporal columns, and we have how well we do on those various social media sites. And we're going to do some other, basically, processing of some of these features. So for instance, maybe we're not as interested in the sentiment of these titles, but what about the words that appear in those titles? Maybe there's something that we can extract, maybe there are particular words that actually jump out. And if this word or this combination of words shows up, then maybe that means that we're going to have, more or less popularity. Maybe that's what we're going to look for. Now, to do this, I'm basically going to take all the words and all the titles and just sort of vectorize them into a table. Show what that actually looks like. If we were to do this just on the first 5 titles, taking all of the words that appear in those titles, basically just putting them into a table like this, this would say that in the first article's title, the word band appeared twice. In the second article's title, the word cloud appeared once. We could verify this. Something just ts.head title values. So it looks like we see band in that first one twice. We see cloud in that second one once. And so that's what this representation is. It's just turning those words into a matrix of numbers. Just counting in all of those. All right, so going to make a model that uses these features. Going to make a model that going to also make use of very loud thunder out the window. But that makes use of the sources that it was published from, makes use of the times of day, and so forth. So here I'm going to put all of those features together, transforming all of them relative to what we need to do with the article titles, what we would need to do with the hours of the day, what we would do with the sentiment values, and so forth. Basically turning those into a new data structure, and I'm going to use that to train 3 separate models. I want to see, okay, well, can we predict those Facebook scores? Can we predict those Google scores? Can we predict those LinkedIn scores? That's what we're going to be doing down here, just training those models. And once we have those working, let's validate. Let's see how we did, and let's try to, make some predictions on some new data. Perhaps before we test the model performance directly, another thing we might want to do, if we're interested in those words in the titles, we might say, okay, well, which of those had a very positive effect on popularity? Which of them had a very negative effect on popularity? And so I'm basically running a little piece of code that's going to pull out, it's going to extract those words, and it's going to say, okay, well, this word apparently is very bad for popularity. We go all the way to the really positive stuff. Looks like the articles that referenced Xbox were particularly popular. Now, some of this might not seem very valuable. Articles that have the word "and" seem to be getting a pretty decent positive boost. Clearly, we could probably clean up our pre-processing on this data, really get rid of words like "to" and so forth. But this might start suggesting that there are certain things that maybe we should be promoting more, writing about more, just topics to be on the lookout for, and perhaps topics that are going to be less interesting. This might inform something like our content strategy, while we also can use things like time of day to think about, just like on a tactical short-term level, when are we posting? Okay. Now let me ensure actually that these were training on all of the features. So train on all of the features. I'll leave that one like that for now. So now we can look at, okay, well, how do these actually perform on data we haven't seen before, brand new articles? Now, not for nothing, over the course of this, performing this analysis, it turns out that the Facebook model does pretty terribly. We do far worse on testing than we do on training. And in fact, we do worse on testing than if we just guessed the average popularity. This is very bad. So maybe we're not getting really anything from our Facebook model quite yet. Looks like our Google model is doing a little bit better. Looks like our LinkedIn model is actually doing quite well. So perhaps that means that we're very good at predicting on these sites. Perhaps it does not. I think I was looking through this data earlier, and I found that a lot of these articles just had scores of 0. So if there's a lot of zeros, these models are probably getting pretty good at predicting the number 0. Maybe not actual meaningful signal that we're really looking for. But in any case, just a quick run through of building a few different models, seeing their training and testing performance. And we could even, generate some predictions and, make a new data frame that kind of shows, okay, well, here's some predictions, or some articles we didn't train on. These are being published in the future from the articles we trained on. How well do we think we're going to do with each of these? And again, this is something that might, as we explore further, start to inform, okay, do we want to be predicting popularity? Is it going to be feasible? What other data do we want? Once we have these three values, digging further into what actions we can actually take that are going to be, a positive influence on, let's say, our, kind of getting back to that original and broad problem, having better social media posts. This is sort of, again, kind of an exploratory, well, it's a lot of exploratory analysis here, so it is a little bit of a non-linear path through some of the things I do as a data scientist. But it really hopefully was just, instructive in relating these, relating these sort of broad business problems into something that we can refine and perhaps start looking for particular values that we might be able to predict, particular types of trends that we might be able to, make use of. And, then thinking about how that relates to the actions that we can take once we sort of bubble back upwards to that real world problem. Sort of working into the very, very technical and working from the technical back into the real world setting. So that is going to conclude basically the bulk of my demo for today. Should have a few minutes later to go over some other questions. We'll note just really quickly, so somebody mentioned, could I share the notebook after the meeting? So that link to the binder notebook is this notebook that I was working in. So you can go there. You can get to the GitHub repository from there. And I'll make a post, I'll post a link to the repository directly. And you can actually download the notebook to run on your own machine as well. All right, let's see. Looks like I need to share and pass things back to Sarah. Oops. And thanks, everybody. And switch things over again to Sarah with a little bit more information about the fellowship.
Thank you, Michael, for that detailed demo. As you mentioned before, that link can access the notebook, and then a recording of this info session will be sent out to all participants. So just going back into some additional information about our program. So we focused on the benefits of our program, but now we want to shift over to the real world application. So more so than just the education and training, but how does that translate into transitioning into a role in data science? So some of the numbers that we're really proud of to share with this group is out of the 82% of our applicants are employed within 6 months of completing the program. And then within that percentage, 97% of those scholars are currently employed outside of academia. So those are really encouraging numbers to see that not only is our program beneficial in the training aspect of it, but we will work with you to help you find placement, and we'll do so, work with you as long as we can throughout the program. And in addition to that, if I can advance to my next slide. So some of the different hiring partners that we work with and some where our graduates are placed. So they're working in 55 differing industries, including computer software, internet, information technology and services, financial services, and biotechnology. And those are just some of the areas. As I mentioned before, all companies have data and they have a need for these roles. So we see our applicants going into areas of retail, healthcare, IT roles as well. These are some of the job titles that you might see. So data scientist, research scientist, data analyst, product manager, co-founder, data engineer. So we are really proud of our graduates and seeing that the variety of areas that they can apply these skills that they've gained through the Data Incubator program and apply them to a variety of roles. And then this is just a sample list of some of our hiring partners. We do have individuals on our team that are dedicated to bringing on new hiring partners. So we are really looking to branch out and have a variety of options available to our applicants as well. And then we do offer financial assistance. We do understand that this is a commitment and it can be challenging. So we offer a variety of options. One of those that we offer is our LEAF income sharing agreement. And with that, you're able to participate in the program without paying any tuition until you've completed the program and are earning more than $40,000 annually. And so we'll help you provide the support to land that role. And then once you have succeeded and done so, then you will start going back and making those payments for the program. In addition to that, we also work with Climb Credit, where you can acquire a Climb Credit loan to pay for the program. And then we also offer STILT, which are loans for international students, to make the program affordable for all of our applicants, regardless of their background and location. And so some important dates to go over for the fellowship program are regular admissions application is currently open. Our cohort, the fall cohort, starts on September 21st. Our deadline for the application is August 1st. And just a reminder that deadline is at 11:59 p.m. UTC time. So just making sure that you're aware of the time zone, and we really encourage individuals to apply at least the day before to make sure that there are no tick issues and you are able to submit your application on time. And then in addition to that, once you've submitted your application, you will have 72 hours to complete the challenge questions. So the challenge deadline after that regular admission deadline would be August 4th, 11:59 UTC time as well. And in addition to this, if you have any additional questions, you can always send them to admissions@thedataincubator.com. We're happy to schedule some time to go over the program in more detail, and then also walk you through some of those finance options and the application as well. So as of right now, I will go ahead and open up the Q&A to some questions and help answer those as best as we can. So one moment while I get that Q&A pulled up. Okay.
And Sierra, I might hop in here because I see that some of the questions in the Q&A seem to be directed towards me. So I'll cover a few of those quickly. So let's see. A great question here. And a few people asking earlier about the notebook. So I did share the link to the GitHub repo and the binder link as well, so you can run it in your browser. But addressing some of these more conceptual problems, or conceptual questions, which are both, I think, really, really relevant here. So at the stage in the problem where I am now, so Tara asked, would the next stage, the next thing I would do, I suppose, be to bring in a neural network, maybe to bring in a more specific classifier? Not necessarily. While there might be some indication that, maybe we can get more signal with a more sophisticated model, maybe starting to reach for a deep learning model or a more powerful classifier, because we did just use linear regression here. If I find that a standard model, just linear regression, is not providing really any signal, this is usually going to tell me that I should reinvestigate, or I should, reconsider perhaps what data I'm using, how I might be pre-processing that data, or what exactly I'm trying to predict. So for instance, maybe we don't want to use just the hour of the day, as I had it broken out as just, these are the ones at 12 o'clock, these are the ones at 1 o'clock. Maybe we would reorient, or, maybe we would transform that hour representation to something cyclical that goes from like 0 to 23 and then back around, right? That's kind of a periodic effect, which might more accurately, describe like a time of day effect. We might consider, I suppose, tuning the way we're representing the words, perhaps getting rid of some of those really common words like is and that we saw, in the features for those word counts, and how they influence the predictions. I also might reconsider the value we're trying to predict. I might say, do we actually want to know the exact popularity? Maybe that's not, are we taking actions? Like, is the, in this case, like the marketing team, are they going to take some action because this post is going to have a popularity of 36 versus 37? Likely not the case, right? So maybe we start looking at other, perhaps simplified label values that might be more meaningful for us. Maybe we just want to know all the posts that are going to make it more than 10 points. We can turn this into a classification problem. Or maybe, rather than evaluating our model's performance based on, just how well it predicts like an individual article, what if we want to predict the popularity, I suppose, so that if we know, here are all the articles we're going to post today or this week, which of them is going to be the most popular? Which of them is going to be the least popular? And granted, if we have even a general sense of predicting those popularities, maybe we don't need to do exactly as well if we can just sort of put them in order. Granted, the models we got so far were pretty terrible, so we're probably not there yet. But overall, what I'm trying to say is that just because a simple model is doing poorly, it's actually almost never an indication that we need to go for a really, really powerful model. We should be able to show something valuable with a simple approach, at least, especially in like the modeling sense. If our, in this case, linear regression model isn't working, we need to reconsider what we're trying to predict and what we're using to predict it. And again, and related to that, why we want those predictions, what we're actually doing with them.
And moving on to another question in the chat. So what percentage of scholars get a job within the next 6 months of the course? So that's a good question. About 82% of our graduates are placed within the 6 months of graduating from the program. And then another question is, what are the challenge and the proposal? I would pass that to Michael to give a little bit more insight into what the challenge looks like on the application.
Sure. So the challenge and the proposal, the challenge will essentially test two kind of broad categories. One will be a little bit more like pure computer science and mathematical reasoning. You'll be asked to, write some code that solves a particular problem that is typically like fairly mathematical in nature, doesn't use data at all. You can write this in any programming language you like. It doesn't have to be Python, for instance. Everything we teach, I guess, aside from writing in SQL directly, is in Python. People solve these challenges using Python, R. I see MATLAB a fair amount. But you'll have some basic computer science questions, well, challenging, but strictly computer science questions. There'll also be a data challenge where you're given a real-world data set and you're asked to compute a number of values based on that data set. That's kind of the overall, bird's eye view of what you're working with. In the capstone proposal, this might be a little bit more difficult to describe it really succinctly, but essentially you're going to be asked to, identify an opportunity for a data science project, sort of, a real-world problem that could be solved with data science. You will, be asked to explain the, overview of your topic in like the application itself, and you will also be asked to, provide any links to any other resources you might have done, looking for some, exploratory analysis, preliminary results, really however much you'd like to do. We often do see links to Jupyter notebooks that might show, some initial exploration of a data set. I also will note that your capstone should use a publicly available data set and should, again, relate to like a real world problem that has like a specific user who would benefit from it. But that's kind of the overview, kind of what you should aim for, what sorts of materials we often see.
Thanks, Michael. Another question I see in there is it possible for readmission? I've been accepted last year for the program, but I couldn't participate. Thanks for your information in advance. So definitely we encourage you to reapply for the program. It is possible for readmission. So I dropped a link in the chat for the application. I would encourage you to apply before that August 1st deadline to be reviewed for this upcoming fall cohort. So we definitely encourage our previous applicants to resubmit their application and apply again.
And I'll hop on another one of these here. So are we focusing more on the algorithm, the model, or more the application, which I suppose would say real-world application with regards to data science and machine learning, I suppose? How is this different from college-level coursework? Well, one thing I would note is that the fellowship is extremely fast-paced and very in-depth, covering a broad range of topics in those 8 weeks very intensely and with a lot of like theoretical rigor and background. But at the end of the day, with a focus at all times on how these relate to real-world problems. So, for instance, in all of the sort of assignments, the mini projects you would be working on throughout the fellowship, you would be working with real-world data sets. You would be doing so, along the lines of things that you might actually want to know about this data that would have some utility. So to that end, because there is always a clear focus on how this relates to the real world, how this relates to actual data, things are not going to be taught from a strictly theoretical standpoint, and we're always going to be bearing in mind, not just what is machine learning, but why is machine learning relevant to the work of data scientists, and why is our work in turn relevant to the, everyone else that we work with, I suppose. That's also going to be supplanted a lot by the soft skills kind of lectures, and when we look at constructing a data science like case study, for instance, again, really drilling into how everything relates to basically the real world.
And I see another question coming through the chat. So it says, has the deadline for the challenge been extended? Last date I got was July 28th. So the current deadlines listed here are on the screen. So the deadline will be August 1st for the application, and the challenge deadline is now August 4th. So we want to encourage you to get your application in and complete that coding challenge before the 4th. And then another question I see is, what is the schedule of the program like? So I think Michael can speak to this as well as far as what your days look like throughout the program.
Sure. So the program is very, it's a packed day. It's a packed week, especially with the, the all online delivery we currently have. It is very structured. We have every day we have a coding challenge, kind of a computer science question that sort of relates to the sorts of questions you might see in a job interview. We then go over that challenge. We have a lecture for that day. Then there's some time to, work on whether it's your mini projects, those weekly assignments, right? Or your capstone project to catch up on lecture material. Then we will have office hours every day in which, an instructor will get on a call with the fellows and, go over particular questions, again, from lecture or the mini projects, more general programming questions as they arise. There are also a number of soft skills lectures, which cover more like career search kind of questions, building those resumes, how to engage in interviews. In addition to all of that, you will work with an instructor and with a group of other fellows to basically refine your capstone groups or refine your capstone projects over the course of the program. So again, it's a very packed day. The mini projects are very long and intensive. The capstones is often a fairly intensive project as well. So we do expect essentially about a 40-plus hour commitment per week. Really is kind of scheduled like a 9 to 5, and we often expect the other work to kind of go past that schedule as well.
And the last question we'll take is it possible to apply for a fellowship from outside of the U.S.? It is definitely possible. We have lots of international candidates. We do typically see that those with a visa that grants U.S. work authorization are able to participate in the program, but we always direct them to contact an immigration attorney. We do have one that we work with pretty frequently who will also, throughout the program, host an info session about immigration and participating in the program. So yes, you are encouraged to apply, and then we do offer some additional financing options for those international students as well. And as I mentioned before, we are wrapping up our hour, so we may not be able to get to all of your questions, but if you do have anything else that you'd like to cover, please send an email to admissions@the-data incubator, and we'll be happy to respond to you there. We can set up a Zoom call as well if you'd like some more information about our program and our financing options. Thank you, everyone, for attending today. Thank you, Michael, for hosting that really detailed info session, and we hope that you enjoyed it. And next week, we'll be hosting another info session on Wednesday, and this will be a Jupyter Hub demo. So if you enjoyed this one, which we hope you did, we would hope you will join that one next week as well.
All right, thanks, Sierra. Thanks again, everybody, and take care.
Thank you, everyone. Bye.